Composite functions, Algebra 2, Common Core. So in Algebra 1, you learned about functions and the function notation f of x. Like this could be thought of as y equals x squared plus 3x minus 5. But we say that y is a function of x. The things that we plug in an x value, we get out a y value. We plug in a domain, we get out a range. Together, they form coordinates that make up the graph and the function in general. And you learn things about determining whether or not something was a function through the vertical line test, and all of that will be revisited. But this lesson is really just getting back into the function notation. Like, what do we mean by f of 3? Now, this is not a composite function. You'll see a composite function when we do something like that, like the function of a function type of thing. But for now, let's start off with the basics. What do we do with f of 3? Now, f of 3 is written instead of f of x. And what's changed is instead of an x, we have a 3. So what we need to do in here is instead of x's, we put 3's. So one good way to think about this is f of input. Whatever we have in that parenthesis for f of, and we throw the little word of between these, like f of x, f of 3. So f of input, whatever we have in there, we're going to put that in here. So for this function here, the variables represent the input. So this is like the input squared plus 3 times the input minus 5. So if I have f of x, it's x squared plus 3x minus 5. If I have f of q, it'd be q squared plus 3q minus 5. Whatever's in these parentheses, I'm going to square it plus 3 times it and minus 5. So in the case of f of 3, I'm going to put that into the input. That would be 3 squared plus 3 times that 3 minus 5. 3 squared is 9 plus 3 times 3 is 9 minus 5. 18 minus 5 is 13. And if we were to look at this, like if we typed y equals into our calculator and look at this graph and look at the table, we would see the point 313 on the table, and on the graph goes through that point. This is from your domain, and this is from your range. But when you plug in a 3, you get out a 13. So a composite function is when you have, a function kind of being plugged into a function. So here I have f of x equals x minus 3, meaning whatever I plug into f, I'm going to do that minus 3. And g of x, whatever I plug into g, it's going to be that cubed. So then we have this notation f of g of 3. And that's how we say it, kind of left to right, f of g of 3. But when we solve composite functions, we go right to left, meaning I start in here with g of 3, and then whatever that value is, I will do f of that. So we do this first, and then we do that. So we kind of go inside to out, in to out, right to left. So first, f of g of 3, I need to know what is g of 3. Now g of 3, when I do g of 3, I have an input for 3. Whatever I plug in there, I simply cube it. 3 cubed is 27. So then it's f of 27. So it's f of the result of g of 3, the result of what's inside of that. It's f of g of 3. Well, g of 3 is the same as 27, so f of 27. And then the rule for f is whatever I plug in, I'm going to do that minus 3. So 27 minus 3 is 24. The mistake a lot of students make here is they see this f of g of 3 and they plug 3 in here, which is correct, but then they also plug 3 in here. That's not correct. You do f of the result of g of 3. And that's a common mistake. But just, think of it as, f of 5 is what? F of 5 is 5 minus 3, 2. Well, f of g of 3 is whatever g of 3 is plugged into f. And g of 3 is 27. That's what's plugged into f. So it kind of works both ways. The other thing that I want to point out here is sometimes you'll see this written a different way. Sometimes you'll see it as f, then a little bubble, g, and that could be in parentheses of 3. This is equivalent to f of g of 3. When you see this notation, like I said, we do, right to left. Well, you would do g of 3 and then f of that. But you'll see both of these notations. And it's not always f then g. Say we wanted to do g of f of 3. Would that be the same thing? The answer is no. F of 3 would be plugging in 3 for f. F of 3 is, plug in a 3 here, 3 minus 3 is 0. And g of 0 is 0 cubed is 0. So f of g of 3 is 24, but g of f of 3 is 0. They're not the same thing. And we'll actually learn, not for a while, but when we get to something called inverse functions, that if they end up being the same thing, especially when we plug in x for both of them, then that means they're inverse functions. But these, this is just a linear equation. This is a cubic equation. These two functions have nothing to do with each other, no relation. But we'll get more into types of functions and their relations and stuff like that in another lesson. Now, so here's another example of that different notation. This is the same thing as h of g of 2. So I do first g of 2, and g of 2 is 3 times that input plus 1. The input is 2. 3 times 2 is 6, plus 1 is 7. So g of 2 is 7, so then we're going to do h of 7. Throw a 7 in here. 3 times 7 is 14, minus 1 is 13. Then it gets a little bit more challenging when you do it with a variable x. And this tends to be where students, have their most difficulty. It's not nearly as hard when I just plug in a number, get a result, plug that result in somewhere else. Not too bad. But here we have to do f of g of x. And notice that when I plug in, f of x, I get an expression. When I do g of x, I get an expression. So when I do f of g of x, when I plug an expression into an expression, I'm going to get an expression. So we're not going to get an answer like 5. We're going to get an expression-looking thing. So what do? Well, f of g of x tells us to first do g of x. And doing g of x is simple because they tell you what g of x is. They tell you when you plug an x into g, this is what you have. So f of g of x is f of g of x, which is x squared minus 4x. So f of g of x, I can replace g of x with what g of x equals. And that really is the same thing we were doing here. I replaced g of 3 with what g of 3 equaled when I plug in a 3 to g. Well, I replace g of x with what g of x equals. And when I plug an x in here, I get that. A common mistake, though, is people think, all right, when I do g of x, I put another x in here, and that becomes x cubed. That's not what we're talking about. Remember, this x is replaced by the input. So is this. So if I were to do g of 5, it'd be 5 squared minus 4 times 5. If I were to do g of y, it'd be y squared minus 4y. Well, g of x is x squared minus 4x. Whatever you plug in, square it minus 4 times that input. So g of x is g of x. It doesn't become then x cubed or something like that. And then f of that. And then this is where students struggle. Now, what is the rule for f of x? Think of it as f of input. What's the rule for f of input? It's 3 times the input minus 1. So if I'm going to do then if I'm going to plug in x squared minus 4x, it's going to be 3 times that minus 1. A little bit of distribution, that's going to be 3x squared minus 12x minus 1. Choice A is correct. The mistake students make when they do f of x squared minus 4x is they tend to leave this x here for some reason. I see a lot of students make the mistake of writing things like 3x times the input of x squared minus 4x minus 1. But remember, this x represents the input, so that is replaced by this. It's not still there, and then I distribute the x's together and things like that. So make sure you don't do that. It is very helpful to rewrite the functions as, instead of having x's, having inputs. Like g of x here, we could have wrote it as g of n is n squared minus 4 times n. And, no matter what I plug into g, it's going to be that squared minus 4 times that. So remember, the x's you have in these functions are simply placeholders for what you plug in. And the reason why they're x's right now is because you're plugging in an x to begin with. All right, so that's composite function. Sometimes it's a simple, a regular function of just plugging in. Sometimes it's plugging in a number, getting that result, plugging that result in somewhere else. And then we go a step further when we plug the function into a function. And this is kind of what I was talking about. If this came out to just equal x, that would mean that f of x and g of x have an inverse relationship. Now, the fact that it came out to be this means that they don't, but that's something we'll get into more another day. All right, that's it for composite functions, Algebra 2, Common Core. See ya.